Jim, this is one of your illustrations that you use to look at soil structure and compaction. Is that correct?
That is correct. And so what we're going to use is we're going to use a brick.
Yeah.
And a brick's made out of what?
Clay.
Clay. So this is actually came from the soil, and we're going to
catch me out, aren't you?
Yeah, I'm going to ask you questions the whole time. So okay. All right. So we're going to use clay to demonstrate. So what I like to ask farmers is, I said, how did we make this brick? And so what we do is you take subsoil and you take soil that's high in clay, you put it in a furnace, you burn off the organic matter, and then you dry it out. And so it gets really hard and really dense. And if you compare that to something like this sponge, which represents organic matter, you'll notice that, for example, this one, they're about the same size, but this one is much denser. Now it's interesting, if I were to dip these both into water, both of these would absorb water, but this one would absorb quite a bit more because it has more pore space in it. This one wouldn't absorb very much at all. So I have to ask you, what do farmers do when they till the soil? They do the exact same thing. They bring the clay up, they dry it out, and it gets really hard. So what do we call a brick laying on top of the soil? We call it a clod, because clods are man-made. Okay? So what we like to do is, if we put some organic matter in between these clay particles, notice that I can compress it, okay? And that it will retain its shape. But if I get rid of that organic matter, what happens is, what charge does clay have?
Negative.
Has a negative charge. So if I put a positive ion in between here, it's going to set up like a cement wall. So you've all seen this. If you've had a farmer that's really tilled the soil and gets it very fine, what happens when it rains?
It all kind of clogs up and you basically form a crust, right?
That's exactly right. It gets really hard. It gets set. So we like to call this cement mix. So these individual particles are micro aggregates. And so these are clay particles with a little bit of organic matter in there, but the majority of the organic matter has been lost. So in the last, say, 50 to 100 years, we've lost 60 to 80% of our organic matter from our soils. Now, if I put some organic matter in between there, and then I add the roots, and I take some of the glues and the polysaccharides in the soil, I can form something that's about the size of a small piece of gravel, small piece of a little bed in the soil. That allows then the air and the water to move down through that soil, and we can demonstrate that. As you look here, as we take this soil that we dug up, you'll notice these little beds here. There's just little pieces of soil particles. I can take that and I can squeeze that in my fingers and turn that into a microaggregate. Microaggregates are going to set up like brick walls, whereas where we have these macroaggregates, where this soil crumbles, it's going to allow air and water to move down through that soil.